Myself, Dr. Sayanti Chatterjee, Associate Professor of Department of Electrical and Electronics Engineering in Institute of Aeronautical Engineering, Hyderabad. Today, I am going to tell about the topic Conductors and Dielectrics. Conductors and Dielectrics is one of the important thing in the electrical engineering. And today, we will discuss the physics between the conductors and dielectrics. So, when we are telling about the conductors and dielectrics, the first question comes in our mind, what a conductor is. So, what is a conductor? A conductor or an electrical conductor is a substance or a material that allows electricity to flow So, what is happening? All the material are all the things in the total universe is made of atoms, and atoms have the two things, one is called the electrons and one is called the proton. So if we are thinking about the any atoms, at the center you can get the nucleus, and nucleus consists of the neutron and proton. Neutron is a chargeless quantity. Neutron is a no charge in the neutron. Proton is the positive charge. It is the positively charged. And in the outer axis, you can find some electrons. You can find electrons. So electrons are negatively charged. When the number of protons is equal to number of electrons, the atoms are in a normal condition. It is an uncharged condition. But if we give any electric field to this charge, the electrons and protons started separating it from each and other, and as a result, the power and the electricity starts flowing. Conductor is the loosely bound atoms. So if we already give some electric field or any potential to it, what will happen? The charge, as these are the loosely bound, the electrons will start moving, and as a result, it will show some flow of electrons, and we know the flow of electrons is nothing but the flow of electricity. That's why electric conductor is a substance and materials that allow electricity to flow through it. Now, what are the properties of a conductor? A conductor always allows the movements of electrons and ions through them. Already I have discussed about this. The electric field inside a conductor allowing electrons to flow within them, and that's why the electric field inside the conductor is zero. There is a general tendency of the electrons to, if this is a conductor, the general tendency of the electron to stay on the outer surface of any conductor. So what is happening as the electrons lies on the outer surface of the conductor, the inside the electric charge density is very, very low or almost zero, and as a result, electric field is already zero. And as I told, the charge density inside the conductor is zero. Many metals are the good conductors of the electricity. Generally, metals are the good conductors, and we know copper, silver. These are the best conductors of electricity. That's why the electric wires are generally made of copper. And the reason why the parts of the appliances that need to pass electricity is made of metals, and especially we use the copper conductors for this work. Next, on the opposite things, unlike the conductors, on the contrary, we will discuss about the dielectric. So, what is the dielectric? Dielectric material is a poor conductor of electricity but an efficient supporter of electrostatic field. So this is little bit confusing. So dielectric material is a poor conductor of electricity as the nucleus, or we can rather tell protons and electrons are hardly bound. So it is we cannot easily break the bonding. So it is a poor conductor of electricity. The flow of electrons is very, very less, but an efficient supporter of the electrostatic fields. So what does it means? If we give, it can store the energy. So this is the property of the dielectric. It can store the electric charges, have a specific resistance. It has a specific resistance. The resistance is very, very high in the case of the dielectric, and the negative temperature coefficient of the resistance. So if the, what is the meaning? Generally, if the temperature rises, the resistance is becoming less. So this is the negative temperature coefficient of the resistance. So this is the dielectric. And what is the insulator? The question comes when we are discussing about the dielectric. The what comes? The insulator. Insulator is also one type of dielectric only. So what is the properties of the dielectric? These are most important. The most important properties of the dielectric is, first one is the electric susceptibility. Electric susceptibility is generally written by Xi. So what is the meaning of the electric susceptibility? This refers to the relative measure. This refers to a relative measure of how easily a dielectric material can be polarized when subjected to an electric field. What does it mean? Generally, we told that the valence or the bonds are very the bonds between the electrons and protons is very much in the case of the dielectric. But what happened if we are increasing the electric field intensity? At a point, it can break down, it can be polarized. It may cause the positive and negative. So this is the electric susceptibility, is a measure of how easily the dielectric material can be polarized. Like for the air, it is 13 kilovolt per centimeter. So if we give the voltage field intensity 13 kilovolt per centimeter, the air, which is basically a dielectric in the normal temperature and pressure, it will breaks down. It also refers to as the material's electric permeability, and it is written by mu. Next is the dielectric polarization. What is the meaning of the polarization? This is the amount of electrical energy stored in the electric field when voltage is applied. As I told that the property of the dielectric, that it can store the energy. So while we are giving the electric field, we can check that when the voltage is applied, how much energy it can store. And generally the value is half into CV square, where the C is the capacitor of a two parallel plates. Since it causes the positive charge and negative charge to flow in the opposite direction, it can nullify the overall field. So this is the dielectric polarization. Next one is the electric dipole moment. I will discuss the electric dipole moment in details in the next slides. But for now, what is the electric dipole moment? If two equal and opposite charges are stay in the distance r, so there is some dipole moment occurs. So the extent to the negative and positive charges separated within a system in a constant value r, and it causes some electric dipole moment. The positive charge tends to come to the negative charge so that it can nullify it, and negative charge tends to go to the positive charge so that it can nullify it. So as a result, it creates some moment, and this moment is known as the electric dipole moment. Next one is the relaxation time. Upon removing an electric field, The atoms in the dielectric generally returns into the original state after some time. The delay is known as the relaxation time. Dielectric breakdown. If the voltage across a dielectric material becomes too great and the electrostatic field becomes too intense, the material begins to conduct current. This phenomena is known as the dielectric breakdown. So, what is the meaning of the dielectric breakdown? So, what is dielectric breakdown? Dielectric breakdown means when the temperature, when the we are giving the intensity to or giving the voltage to the dielectric, but at a certain time, and there is a very less flow of current, which is known as the leakage current. But at a certain time, if the voltage is very high or the electrostatic field is too intense, or means too intense means in the small area we are giving very high voltage, dV exponential gradient is very high. What will happen? The which is the electrons and protons bonding breaks down and it again behaves like a conductor and current will start to flow within this. So this is called the dielectric breakdown. In component that uses gases and liquids as the dielectric medium, the condition reverses itself if the voltage decreases below the critical point. So these are the example of the dielectric. But if we use the solid dielectric materials like any porcelain or anything, this dielectric breakdown sometimes breaks the solid material and it creates some puncture or permanent damage in the case of the dielectric. Last point is the dielectric dispersion. So what is the dielectric dispersion? This is the term refers to the maximum polarization attained by the dielectric material. So what is the maximum value, maximum polarization it can attain within a time, and it is affected by the relaxation time. Already we have discussed the relaxation time. So dielectric dispersion depends on the relaxation time. So we discussed about the dielectric properties. What are the dielectric properties? First one is the electric susceptibility, dielectric polarization, dipole moment, relaxation time. Fifth one is the dielectric breakdown and sixth one is the dielectric dispersion. Next we will move to our next slide. What is current density? So we already know what is current. If there is a flow of electrons, then what will happen? Due to the flow of electron, in the opposite side current will flow. So what is current density? If the charge is distributed in a given area, current density, as the name suggests, is defined as the current constituted in the given area. Current density means current per unit area. We can tell current intensity, capital J, we write it by the capital J I by A. So what is the unit? The unit is A by meter square. Ampere per meter square is known as the current density. Now, if we take it in a very small area, infinitely small area, so we can write J is equal to di by ds. So what is di? Di is equal to J into ds, where capital J is known as the current density. Now one question is there. So we know J is equal to J into ds, or we got the equation, or we can write J is equal to di by ds. We can write J is equal to di by ds. And what is I? I is the current. So we can write d by ds and I is equal to dq by dt. So dq by dt is also known as the current. So current density is equal to d by ds into dq by dt. Or we can take it as the d by dt dq by ds, charge per unit area. What is this? J is equal to charge per unit area. So we can write dq ds is equal to rho s. So d by dt into rho s. What is rho s? Rho s is known as the charge. Sorry, we can write it detailed surface charge density. So you can write that the J is equal to surface charge density. This is the another definition. Now what is the types of the current density? Current density is basically three types. One is called the convection current, conduction current and displacement current. What are these three? So first we will discuss about the convection current. Convection current means if no external force or external voltage is applied, there is a small flow of electrons in any medium, and as a result, or if any conductor is there, so the flow of electrons is known as the convection current. Let me give an example. In the time of the thunder and storm, or we can get the clouds are full of the negatively charged, and due to the cloud, due to the induction, the ground or the earth become the positively charged, and the general tendency is the electron should attracted by the positive charge, and there is a flow of current. So this is called the convection current. Next one is the conduction current. This is due to the drift velocity of the electrons. Next one is the conduction current. What is the meaning of conduction current? Conduction current means while we are, this is the general current. Generally the conductors in our household or somewhere is in the ideal condition. But whenever we will give the voltage, we are connecting it with a supply. What will happen? Some current will start to flow, and as a result, there is some flow of electrons or flow of current. This type of current is known as the conduction current. And what is the conduction current density? The current per unit di by ds, unit surface area. What is the displacement current? Displacement current is basically the leakage current. While we are connecting any dielectric material with any external voltage source, there is a small flow of current, and this type of flow of current is generally known as the displacement current, and generally current density has the two parts. One is the conduction current density, another one is the displacement current density. Next we will discuss about the drift velocity. What is the meaning of the drift velocity? Drift velocity is the average velocity with which the electrons drift in the presence of the electric field. So what is this? Say this is a conductor. This is a conductor, and we are connecting the conductor with an external supply of voltage V. So what will happen? Due to the field intensity, the electrons will start to move towards the positive electrode, or we can call it cathode. So it will start to move in the positive electrodes. Drift velocity is the average velocity with which electrons drift in the presence of the electric field. So it's the drift, as it is drifting So it is known as the drift velocity and it causes the electric current. Generally the direction of the current is always the opposite side, of the electric field. And there is another type of velocity which is known as the thermal velocity. Sometimes if we hit some conductors, there is also some random motions of the electrons. Due to the overheating, some electrons will come out, but there is no any proper direction. It causes some random motion and in collision of the metal ions. That's why, as this is a random motion, it never causes any current. So only if we connect a conductor with an external battery source, the electrons goes in a particular way, and this is called the drift velocity. Next is the derive the Ohm's law in point form. So everyone will tell Ohm's law is very easy. What is in the Ohm's law? Okay, that's true. But Ohm's law, what is the basics of the Ohm's law? What is Ohm's law? If the temperature, pressure and other physical activities remains constant, we can tell voltage is directly proportional to the current, or the voltage applied to any conductor is directly proportional to the current. And what is voltage? Voltage we can write R into I. What is R? R is the proportionality constant which is known as the resistance. And what is resistance? Rho L by A. What is rho? Rho is known as the electric resistivity. And what is this? Rho is again 1 by sigma. What is sigma? Sigma is the conductivity of a material. And as we are discussing of the conductivity, we will start the Ohm's law from the conductivity. And it is known as the Ohm's law in the point form. And what is the physics behind the Ohm's law? So, under the electric field, free electron starts moving, and after some times it attains the constant velocity, and this velocity is known as the drift velocity. Already we have discussed this. If we keep one conductor and we connected it with a battery, the electric field, under this electric field, the free electrons of the conductor started moving in a particular direction with a constant velocity, and current will flow in the opposite direction, and this velocity is known as the drift velocity. So we can tell that drift velocity is directly proportional to the electric field intensity. If we increase the value of the electric field intensity, the drift velocity will also increase. So what is the drift velocity? If we remove the proportionality constant, Vd equals to minus mu e. Vd, drift velocity, is equals to the minus mu e. What is mu? Mu is known as the mobility constant. The mobility constant differs from material to material. As in case of the copper and silver, the mobility constant is very high. So drift velocity is high, and it is a very good conductor of the current. Again, we have discussed in the last part that the J current density is equal to rho V. Rho V means volume charge density into Vd. What is Vd? Vd is nothing but the drift velocity. How we are getting this one? We got that J is equal to di by dt. And if we change it in the rho V, then we can get J is equal to rho v into dt, or we can write it. What is I? I is nothing but the dq, this is di is equal to di by ds. And what is the I? I is already we have discussed, dq by dt. And what is dq by dt? dq by dt is nothing but the, if we write rho v dv, we can write as the rho is ds. What is q? I am writing here. Already I have discussed this in the other classes, in the old videos, but again I am telling once. What is dq? dq means charge is equal to, we can write rho l dl equals to rho s ds is equal to rho v dv. What is rho l? Rho l is the line charge density, number of charge per unit length. What is rho s? Number of charge per unit area. And what is rho v? Rho v is nothing but the number of charge per unit volume. So we are using here the rho v dv. So if it is rho v into dv, then what will happen? We know what is the value of the, we can also write by dt. Now we can also write what is the meaning of the dv volume. Volume means length into surface area by dt. We can write this, the dl, what is the surface area by the width is known as the, so we can also write this d by ds. ds is cancelled out. So dt rho v dl. What is dl by dt? The L dl by dt means it is nothing but the velocity. So from here we are getting rho v into vd. So the relation is J is equal to rho v into vd. Current density is equal to volume charge density. Volume charge density, and vd is nothing but the drift velocity. So we got this one. Now if we compare, if we put the value of vd here, what we got? J is equal to rho v into minus mu e. So minus rho v mu e. And what is the rho v into mu is known as the sigma, volume charge density into mobility constant is known as the conductivity of the conductor. And this form is known as the, and this is the Ohm's law in the point form. So this is the derivation of the Ohm's law in point form. J is equal to minus sigma into E, or sigma is equal to rho v into mu. Next is the derivation of the expression for equation of continuity, or we will discuss about the continuity equation. What is the continuity equation? Continuity equation means when current flows through any circuit, how much continuity will be there. It has two things. One is known as the integral form, another one is known as the point form. First, we will discuss the continuity in the integral form. So let's start that Q is the charge enclosed in a surface. We will always take the charge which is enclosed in a surface, closed path. So what is current? Current, or we know that the current is equal to dq by dt. And why we are taking the minus dq by dt? Because the current direction is already in the opposite direction of the electrons. What is current density we discussed? We discussed the current density J is equal to di by ds. So what is I? I is nothing but if we take the integration as we are doing in the integral form, we are taking the integration. I is equal to j integration of j ds. So if we compare these two line 1 equation, this equation and this equation, we can write both are I dot ds is equal to minus dq by dt, and this equation is known as the continuity equation in the integral form. The integration of j dot ds equals to minus dq by dt. On the contrary, now we will discuss the expression of the continuity in the point form, and point form is also known as the derivative form. So again we will start. We already got that the integration of j ds is equal to, we are using here Stokes theorem or divergence theorem. What is in the divergence theorem? Already we have discussed in the previous slides in many times that integration of, if we want to change that j dot ds, if we take the divergence of g, it will go in the next level. So ds to dv if we want to take, then we have to, instead of j, we have to take the grad j. I am giving one more example. Say we have x dx. So this is a one line in a closed path. If we want to change it, it will be grad x into, instead of dx, it will be now ds, where s is equal to xy in a closed surface. If we want to change it in the volume, it will be grad of grad x, then dv, where v is equal to xyz. We are increasing the level. So again from the previous one we got I equals to j dot ds, and we are always taking the current in a closed path. No, in open path current is not flowing. And also we got in the previous slide current is equal to I equals to minus dq by dt. So if we compare these two equation, I is equal to j dot ds and I is equal to minus dq by dt. So already we check this one. J dot ds is equal to minus dq by dq by dt. And what is j dot ds in a closed path? In a closed path, j dot ds is equal to grad j into dv. So equals to integration grad j dv. So if we compare these two, so minus dq dt is equal to grad j dv. So what is q? Q is equal to, we are taking the dt here, grad j dv. So if we take the derivative in the both side, we are getting minus d rho v dv by dt is equal to grad j into dv in a volume. So integration of rho v into dv is equal to grad j. So we can tell this is the continuity equation in the point form. So I am telling it in once more time. First we know that in a closed path j dot ds is equal to grad j dv. And secondly we got I is equal to integration of j dot ds. So what is current? Current is equal to I into minus dq by dt. If we compare these three, the blue, green and yellow three circles, we can write minus dq by dt is equal to integration of grad j into dv. Again, We know that the what is Q? If we take the dt inside, what will happen? If we take the dt inside, that Q is equal to rho v dv. That also we got from the previous slide, that the Q or the current density J is equal to rho v into dv. This is the, as rho v is equal to dq by dv, charge per unit volume. So this is the, we got this equation, we got this equation. So again, if these two blue are compared, so what will happen? In place of Q, in the place of Q, we are putting the rho integration of rho v dv by dt is equal to integration of grad j dv from this equation. This and this equation compared, we got this equation. So both sides, if we take the only the integration, what will happen? We are taking the dt inside, then it will be d rho v by dt del v is equal to grad j dv, and both are the volume, and both integration is the with respect to volume. We can remove it and we got del rho pv dt by is equal to integration of grad j dv. This is known, actually it will comes like, so del rho pv del t is equal to grad j dv we are cancelling in the both side, and this is known as the continuity equation in the point form. So we are doing one small problem in here, and this problem is also in the question bank. A conducting wire of diameter 1 millimeter and the conductivity is equal to 5 into 10 to the power 7 ohm per meter has 10 to the power 29 free electrons per meter cube. When the electric field 10 millivolt per meter is applied, determine the charge density of the free electrons. So what is the first one? First one is the diameter is 1 millimeter and conductivity is this. And the charge is, first one is the, we have to calculate the total number of the free electrons. The charge density, what is the total charge? 1 electron is minus 1.6 into 10 to the power 19. So if the number of electrons is 10 to the power 29, it will be total charge will be 1.6 into 10 to the power 19 for 1 electron. So for 10 to the power 29 electrons, it will be minus 1.6 into 10 to the power 10. This, and what is the unit? Unit is the coulomb. Next, if what is the next? Next is the, what is the total charge density? We know the diameter is 1 millimeter. So 1 millimeter means radius is 0.5 mm. Always we will change everything in the meter, so it will be 10 to the power 5 meter. And what is the then ds? ds is equal to pi r square. Pi value we know, r square value we know, so we can easily calculate the charge density. What is the current density? Current density formula is J equals to sigma into E. What is the value of the sigma? The sigma value is given as the 5 into 10 to the power 7. What is E? E is the field intensity. But here field intensity is also given 10 millivolt per meter. So sigma value we know. What is the sigma value? The sigma value is 5 into 10 to the power 7. And what is the E value? 10 into 10 to the power minus 3. So it is coming as 50 into 10 to the power minus 4. And what is the unit of the current density? Ampere per meter square. And last one is the current in the wire. How to get? We know the current density. What is I? Actually, di by ds is equal to j. So I is equal to j into ds. J value, current density value we got. S is equal to pi r square. R value is also given. So from there we can easily calculate the current density. So what we have discussed till now? We have discussed about the, and last one is the boundary condition between the conductor and free space. When an electric flux passes from one media to another media, the characteristics change, and this condition existing in a boundary is known as the boundary conditions. Before starting this, we have some assumptions we have. First assumption is field intensity and flux density inside a conductor is 0. Charge only appear on the surface. The charge density within the conductor is 0. So this is a path. This is a conductor. We are taking the three assumptions. The field intensity inside the conductor is 0. Charge only resides on the outer surface, and the charge density within the conductor is 0. So we are taking the conductor width as delta W and conductor height is as the delta H. This is the boundary, this is the free space, this is the conductor, and this is the boundary. We will check as the conductivity and free space is the dielectric, basically how it affects the field intensity. So we can tell that the field intensity has two components. One is the tangential components, another one is the normal components. We are assuming that this is the field intensity E, and it has two components. One is the tangential components and another one is the normal component. Tangential component and normal component. So, as we discussed, we know in a closed path, the field intensity is 0. So, E dot dl is equal to 0. So, what is the meaning of E dot dl? That E AB path plus BC path plus CD path plus DA path. We can write E dot dl A to B, B to C, C to D, D to A equals to 0. Now, we can see this one is within the conductor, this path, CD. CD path is within the conductor. So, it is already 0 because the field intensity, we assume that the field intensity inside the conductor is 0. So, as this is the value is 0, so E dl A to B plus E dl C to B plus E dl D to E equals to 0. Now, we can also write this is the AB, BC, CD, D. We have 4 paths. Now, we can also write the E A to B, E dot dl. This is the tangential component. This is the tangential component, and tangential component of the field is always 0. So, A to B is also 0, as this is the parallel to the CD and this is the tangential component. So, we can write that the EAD plus EBC equals to 0. I will tell once again. We can write, I am writing it little. We got A to B E dl plus B to C E dot dl plus D to A E dot dl is equal to 0. We got this. Now, this portion delta from 2 to C, this is inside, this is also inside. So, this is 0, this is 0. So, what is the value? We can write A to B E dot dl plus 2 to B E dot H by 2 plus 1 to A. 1 to A. But the direction is opposite. So we can write EH by 2 equals to 0. So these two will be, as this both value is same, they will be, total will be 0. So we can write A to B E dot dl, A to B E A dot dl will be 0. And what is the value of A dot B? This is the delta W. So this is the boundary condition, the intensity of of any field when the current flows from the conductor to the free space. This is true for any other medium. Say from conductor to oil, conductor to dielectric, conductor to conductor. This is the same. So, we have discussed today about conductor, properties of the conductor, dielectric properties of the dielectric. Then we have discussed about the drift velocity, different types of current density, Ohm's law in point form. Next, we have discussed about the continuity equation in integral form and continuity equation in the point form, and we have discussed about the boundary conditions also. So this is my today's lecture, and next class we will discuss about the dipole moment and polarization. And thank you all.
Like, share and subscribe. Hit the bell icon for more updates.